Hello, today we're continuing in the A-Level Physics Revision series looking at friction. Frictional forces act to oppose motion or oppose a force which is attempting to cause motion. So if we have a level surface, we'll start with a level surface, not an incline, and we place a block on it. You could think of this as a bookcase, and the bookcase has mass m. Then there will be, of course, a gravitational force acting downwards, which equals mg. Now, if I attempt, this is me attempting to push that bookcase, I may use another force, that's my force, and I attempt to push the bookcase, it won't move. You will have tried to do this if you've got something heavy, you try to push it along the ground, it doesn't move. You push a bit harder, it still doesn't move. This means that there must be a force that is equal and opposite. We'll call this the force of gravity so we don't confuse this force. But here's a force F in this direction. If the bookcase doesn't move, there must be an equal and opposite force F acting in the other direction, because otherwise there would be movement. We know that there would be movement because we know that the force is the mass times the acceleration. So if you apply a force, then the mass determines what the acceleration of that body is. If there is no acceleration, which means there's no movement, then the force that I am applying to push the bookcase in one direction is balanced entirely by the frictional force which is opposing the movement. So here is the clever thing about friction. As I increase my force against the bookcase, the frictional force exactly matches it. It grows to precisely oppose it. It obviously can't increase beyond my force, because if this force, the frictional force, were greater than this force, then the bookcase would actually paradoxically move in this direction, which it clearly isn't going to do. So that's the clever thing about frictional forces. Frictional forces are called non-conservative forces because they act in this peculiar way. They always grow to the point where they just are enough to oppose the force that is trying to cause movement. But of course, frictional forces can't last forever. Eventually, if I make that force large enough, I will overcome the frictional force and the bookcase will slide in this direction. And of course, the question is, what is the force that I have to apply that will overcome the frictional force? In other words, what is the maximum frictional force that you can get, so that if this force is greater than that maximum frictional force, you will eventually make the bookcase move? Well, the answer is that there is always a normal force which is at right angles to the surface. Now remember that the normal force is always at right angles to the surface. This will be important when we get to an inclined plane. The normal force is always right angles to the plane. What is the value of that normal force? Well, it's the gravitational force in the other direction. It's also equal to mg. Why must that be the case? Because if these two forces did not exactly balance, then there would be movement in the y direction or in the up and down direction. Clearly there isn't any movement. Bookcases do not suddenly go upwards. So therefore the normal force acting, which is essentially Newton's third law, the bookcase exerts a force on the floor exerts a force on the bookcase. So then the normal force is the mass of the bookcase times g. So we've got a normal force, and what we say is that the maximum frictional force, which we'll call, that's the frictional force, and we'll call it maximum. The maximum frictional force is what's called a coefficient of friction, mu, and I will put a little s beside it, and I'll tell you what that means in a minute, times n, where n is the normal force. So the maximum frictional force is the coefficient of friction times the normal force. Why did I put a little s there? Well, that stands for static. There are in fact two coefficients of friction. There's mu static and mu kinetic. Mu static is the coefficient of friction, which is the coefficient which applies when you try to get something moving in the first place. In other words, going from stationary to moving. Mu kinetic is the coefficient of friction which applies once you've got something moving and you want to keep it moving. So for example, and always mu s is always greater than mu k. So if you take a wheelbarrow, for example, you need to give it a hefty shove. Let's say the wheelbarrow is full of bricks. You need to give it a heavy shove to get it moving, but once it's moving, you don't need to apply quite so much force to keep it moving. So you need a much higher force to get the wheelbarrow moving than you do to keep it moving. So mu static for this wheelbarrow full of bricks is higher than mu kinetic, because you need a higher force to get the wheelbarrow moving in the first place. Most of the time in exam questions, it is mu static that you'll be looking at. What does it take to get something to move? So now we're ready to look at the more complicated case of a block on an inclined plane. So here is my inclined plane, and it is an angle alpha. And you have to imagine that I can actually vary that angle by tipping the plane up like this. And here is my block on the plane, and the block again is of mass m, which means there will be a gravitational force which of course acts vertically downwards with a force mg. There will be a normal force, and you'll remember that I stressed this point, the normal force is always perpendicular to, or at right angles to, the plane. So the normal force goes off at right angles. And of course there will be a force acting down the plane, which will be attempting to make this block move, and that force will be the component of the gravitational force mg, but in this direction. And we'll have to work out what that is. So let's call it x for the moment. And of course there will be a frictional force which will oppose movement. So the frictional force moves in this direction. And for a little while, as you start to move the inclined plane upwards, the block will not move. And the block will not move because the force that is trying to pull it downwards, which is simply the gravitational force in this component, will exactly balance the frictional force, so consequently there will be no net movement. But when that angle becomes great enough, the force acting down will be greater than the maximum frictional force acting upwards, and the block will move. And what we want to know is, what is the condition for the block to move? In other words, what does that angle need to be? Well, first we need to calculate the values for x and n. Let's try x first of all. Well, if we want to resolve mg into this direction, what we do, of course, is we take mg and we say we can resolve it into that direction, and of course we could also, if we wanted to, resolve it into that direction. We will need to in just a moment, actually. But first of all, how to resolve it in this direction? Well, we drop a perpendicular, we say that this is mg, this is x, and this angle here you can show is alpha, and so you get that x over mg equals sine alpha. So x is the component of mg in this direction, which means that x is simply mg times sine alpha. So the component of the gravitational force acting down the plane is mg sine alpha. What about the normal? Well, the normal is just the opposite of the component of mg acting in this direction, perpendicular to the plane, which of course is the value of this here. And using exactly the same geometry as we did before, you can say that n is equal to mg, but this time it will be cosine of alpha. That's just plain geometry, because now the angle will be 90 minus alpha, and the sine of 90 minus alpha is the cosine of alpha. So n is mg cosine of alpha, which means that the frictional force acting upwards is, from what we showed before, the maximum frictional force will be the mu static times the normal force. And since the normal force is mg cosine alpha, that means that the maximum frictional force acting up the plane is going to be mu static times n, which is mg cosine of alpha. So we've got a force acting down the plane of mg sine alpha, and the maximum frictional force acting up the plane, opposing the movement, is mu, I should make that clear, that's a mu s mg cosine alpha. And the condition for the block to start sliding, in other words, to overcome the maximum frictional force, is that x must be greater than the maximum frictional force. So x, which is mg sine alpha, must be greater than the frictional force, which is mu s mg cosine alpha. Well, you can see that mg's are going to cancel on both sides of the equation, and that means that sine alpha, if you divide both sides by cosine of alpha, sine alpha divided by the cosine of alpha must be greater than mu s. But sine alpha divided by the cosine of alpha is simply the tangent of alpha, which must be greater than mu s. So here is our first big conclusion, that the block will start to move down the plane, in other words, it will overcome the frictional force, when the tangent of this angle alpha is greater than the frictional force, the frictional coefficient mu s. Now what determines the frictional coefficient? Well, it obviously is going to be determined by the nature of this substance of which the block is made and the surface itself. So the coefficient of friction will always be determined by the substance of the material that you want to move and the surface that it's going to be moving on. So for example, if both of these are ice, then the frictional force is going to be the frictional coefficient is going to be very small, and the angle, therefore, tangent of the angle will only need to be very small before it moves. Whereas if this is a block of concrete on a road, then the angle is going to be quite steep because the frictional coefficient is going to be large, therefore the tangent of the angle will be large. But the point is that it depends on the materials that you are using. But as we shall see in a moment, it doesn't depend on any other factor. In particular, you'll notice that this condition has nothing to say about the mass of the object. All that is required is that the tangent of the angle should be greater than the coefficient of friction, which is independent of the mass. So you could have two blocks, as long as they're made of the same material and as long as they are sliding down the same incline, you could have a block of 1 kilogram and you could have another block of 10 kilograms, and both will start to slide when the angle is such that the tangent of the angle is greater than the coefficient of friction. That's counterintuitive, because you might think the heavier something is, the more difficult it will be to get it to move, but that is not true. Now I'm going to take the block on an incline with a slight twist. So it's exactly the same position as we had before. Here is the incline at an angle alpha, and again you have to imagine, let me just draw that alpha better. So again you have to imagine that the incline can be moved up gradually so that alpha increases. Here is my block of mass m. Once again there will be a gravitational force acting vertically downwards of mg. There will be a component of that force acting down the plane, which is mg sine alpha. There will be a normal, which is perpendicular to the plane at right angles to it, and that will be mg cosine alpha, and therefore the maximum frictional force, which we'll call FF max, is going to be mu s, the coefficient of friction, times the normal, which is mg cosine alpha. That is exactly what we had before. But now here is the twist. What I'm going to do is to put a little pulley here, and I'm going to attach this block to the pulley by a rope which goes over the pulley, and I'm going to put a mass of mass capital M on the pulley. So there's a rope attached to the block which goes over the pulley and has a mass capital M on it, which will of course exert a gravitational force of capital M times g acting down, and that force mg will be transmitted through the rope and will be effectively pulling upwards on the block. And the question now is, what happens? Well, there are three possible outcomes. Firstly, and obviously this will all depend on the angle alpha, the first possible outcome is that the force of gravity caused by the block and its component mg sine alpha is greater than the combination of the frictional force, which is attempting to stop it moving downwards, plus the gravitational force of this block. That's one option. So it slides downwards because it overcomes the two forces that are trying to stop it. The second option is that actually this mass is so great that it pulls the block up the incline. And if it does that, then mg must be greater than the component of the force going downwards, which is mg sine alpha. And of course now friction will operate in the other direction, because friction always opposes the direction that it's going to move. So if this mass here is going to win, and it's going to be able to pull the block up the incline, the frictional force will act down the incline. So now mg will have to be greater than little mg sine alpha plus the maximum frictional force. That's the second option. The third option, of course, is that neither is the case and the block doesn't move, because mg isn't great enough to overcome the two forces that would act downwards, and mg sine alpha isn't great enough to oppose the two forces that would act upwards. Remember, friction is always perverse. It always opposes the direction that you think the block is going to move. So let's just write down what happens. If the block is going to move up, which is the first of our possibilities, if the block is going to move up, then that must mean that mg, capital MG, is greater than the forces that are acting downwards, which is mg sine alpha plus the frictional force maximum, which we've already worked out is mu s static times mg cosine alpha. So that means the block will move upwards. The second possibility is precisely the opposite, that in fact this force downwards is greater than the forces acting upwards. So the force downwards is mg times sine alpha must be greater than the forces acting upwards, which will be the mass mg plus the frictional force, because now that is opposing the movement downwards, so it's acting upwards. And if therefore the downward force is greater than the mass plus the frictional force, and again frictional force maximum is going to be mu s mg cosine alpha, if that is the case, then the block will move down the plane. And of course the third option is that there is no movement, and that means that neither A nor B is true. And obviously which one pertains will depend on several things. It will depend on the relative sizes of these two masses. It will obviously depend on the coefficient of friction between the block and the surface, and it will also depend on the angle alpha. So in an exam question you will be given some of this information and you will be invited to calculate which of these applies. And the final part of the frictional question that I want to deal with today is the question, does it slide or does it topple? So here is my incline, and again you have to imagine that the angle alpha is increasing all the time as you move the incline up, and we put on it a block, and you'll notice that I draw the block slightly differently than the way I did before. It's a tall block. And the question is, as you increase alpha, what happens first? Does the block slide down the incline or does it topple over? In other words, does the block, which is sitting here, fall over as alpha increases? How can I work out what happens first? Well, once again, we'll assume that the block has a mass m, so the force acting down will be mg, And earlier in this video we calculated the condition for that block to slide. It was that the tangent of alpha must be greater than the coefficient of friction, or the static coefficient of friction. We said that it didn't matter what the mass of the block was, and it didn't matter how much of it was in contact with the surface. All that matters is that the tangent of the angle must be greater than mu s. So you know the condition for when it will slide. So the real question is, will it topple before it slides? Well, how do you know if it's going to topple? Everybody has a centre of mass, and the centre of mass is the point at which, within the body, all the mass of that body can be thought to reside. Now, typically for an exam, you will get a regular body, otherwise it will be very difficult to work out. So if you have a regular body, a block like this, then the centre of mass will be at the point where the two diagonals coincide. It will be a regular point. It will be halfway down this side, and it will be halfway along this side, unless you're told otherwise. That's where the centre of mass is. And all the mass can be thought of as acting from that point. So if the mass of the body is m, then the gravitational force exerted from that point is mg. Now here's the point. As long as the gravitational force acting from that centre of mass passes through the base, the block will not topple. But if you turn the block like this, and here's the centre of mass, now you'll notice that the vertical gravitational force falls just outside the base. And as soon as it does that, the block topples. So if you've got a situation like this, where the force is just inside the base, the gravitational force acting downwards, that is supposed to be vertically downwards, it doesn't look it, but it's supposed to be. Provided it is falling within the base, the block will not topple, because it has the stability that the centre of mass is over the base. But as soon as the block goes further than that, then the block will topple. So if we draw now our angle, there's alpha, there is our block, and I've drawn it so that it's just at the point where it will topple. It's just at the point at which the centre of gravity is over the corner. If you move that angle up any more, that block will topple. Then how can you calculate at what angle you need to be? Well, you'll need to know the values of these two sides here, which I'll call A and B. A is usually half the total, and B is usually half the total side here. So half the base is A, half the side is B, unless you're told otherwise. And if this angle here is alpha, then this angle here is also alpha. And you can now see that A over B is equal to the tangent of alpha. So when A over B, when the tangent of alpha is equal to A over B, then the block is ready to topple. So now you've got the condition. In order to slide, the tangent of alpha must be greater than mu s. In order to topple, then the tangent of alpha essentially must be greater than A over B, because at A over B it's on the verge of toppling. If it gets greater than that, it will topple. So you've just got to find out which angle is the lower. If the angle is lower for sliding, then it will slide down. If the angle is lower for toppling, then it will topple. In other words, what angle do you get to first? The angle for toppling or the angle for sliding? And there's just two separate calculations to calculate the tangent of the angle, and whichever is smaller, it will either slide or topple accordingly.